Hello geometry students. In this video we're going to talk about triangle congruence, and so we're going to be proving some triangles congruent today, and we're going to start with this first proof where we're given some information about a pair of triangles, and we're going to prove them congruent. And at this point the only method we have of proving triangles congruent is the definition of congruent polygons, which says two polygons are congruent if and only if all of their corresponding parts are congruent. So if we're trying to prove that two triangles are congruent to each other, what we need to prove is that we have 1, 2, 3 pairs of angles congruent, and then 1, 2, 3 pairs of sides congruent. So let's get to work on this proof. It's going to take us a little while. In fact, it's going to take 11 steps. So you might want to plan accordingly and make sure that you can squeeze 11 steps in this space. It's going to be a bit of a challenge. So because we're kind of short on space, normally when we talk about the anatomy of a proof, we always have a given statement, we have a proof statement, we have a labeled diagram, and then we usually have a heading for our statements column and our heading for our reasons column. But to save space, I'm not going to put those column headings. I'm just going to go ahead and start with step number 1. Now, normally we want to start with the given statement, and a lot of times we'll write all of the given, but in this proof I'm just going to take one piece of given statement, one piece from the given statement at a time. So let's start with the fact that we have our first piece of given information. We have a segment PQ that is congruent to a segment QR. So why is that true? Because we are assuming that it's true, so we'll write given. Given just means we're going to assume this information is true. So since it's true, let's mark it on the diagram. We're going to mark that segment PQ is congruent to segment QR. Okay, and by the way, let's look at our proof statement. What are we trying to prove? We're trying to prove that this triangle PQS, PQS, the triangle on the left, we're going to prove that it's congruent to triangle RQS, this little triangle on the right. Okay, so we have one pair of sides congruent. We only have 5 more corresponding parts to go. So since we've already used this piece of given information, I'm just going to put a check mark by it because we've used that. And then I'm also going to keep track of what we have so far. To the left of my statements, I'm just going to put a little S to remind me that I have one pair of sides congruent. Now let's go on to the next piece of given information. The next piece of given information says that S is the midpoint of segment PR. So let's go ahead and jot that down. So in statement number 2, we're going to say that S is the midpoint of segment PR. Okay. Now, if S is a midpoint, what does that mean? That means, what is the definition of midpoint? A point is a midpoint if and only if it cuts a segment into 2 congruent segments. So that midpoint gives us another pair of congruent segments. So I'm going to say in step 3 that segment PS is congruent to segment SR, okay? And, I forgot my reason number 2 was given, okay? And now my reason number 3, why is segment PS congruent to segment SR? Because we have a midpoint. S is a midpoint, so it divides the segment into 2 congruent segments. So for reason 3, we will say definition of midpoint. Okay, so I'm going to put a check by that second piece of given information, and then let's go ahead, and since now we have 2 pairs of sides congruent, let's go ahead and mark that second pair, and then let's talk about a third pair of sides that the triangles have congruent. Now, this is not from our given information, but notice that the triangles share a side, and that side is going to be congruent to itself because of the reflexive property of congruence. So let's go ahead and mark it congruent, and then we're going to say in step 4 that segment QS is congruent to itself, and the reason why is because of the reflexive property of congruence. So now you'll notice that we have 1, 2, 3 pairs of sides congruent, so we're halfway there. So now let's work on finding 3 pairs of angles congruent. So let's go back to our given information. Our next piece of given information says that we have segment, a segment QS that bisects angle PQR. So if segment QS bisects angle PQR, well, what does the definition of angle bisector say? As ray as a segment bisector if and only if it divides the angle into 2 congruent angles. So let's go ahead and state that given piece of information, that segment QS bisects angle PQR. Okay, that information was given. And now, since we have that angle bisector, we can say that angle PQS, that's this angle right here, PQS, is congruent to angle RQS, which is this angle right here, okay? And so now we have our first pair of congruent angles. Now, let's first of all put a reason. The reason is because of definition of angle bisector, okay? And so I'm going to put an A right here because that's my first pair of angles we have congruent, and I'm also going to check off that next piece of given information. Okay, so now, if we go to the next piece of given information, we're told that angle P is congruent to angle R. So that's this angle and this angle. That gives us another pair of congruent angles. So in step 7, we're going to say that angle P is congruent to angle R. Okay, that was our next piece of given information. So the reason is given. And then let's mark that in our diagram as well. First of all, we need to go back. I forgot to mark angle PQS congruent to angle RQS. So let's go back and do that with one arc. And now this next pair of angles, we have angle P congruent to angle R, okay? So if you look at our list, we now have 1, 2, 3 pairs of sides congruent and 1, 2 pairs of angles congruent. So we're almost there. Let's go back to our given information. The next piece of given information says that segment QS, this one, is perpendicular to segment QR. All right, so let's write that down. Step 8, we have a segment QS that is perpendicular to segment PR. That was another piece of given information. Okay, now how is that going to help us? Well, we might remember a theorem in our last unit that says if we have a pair of perpendicular lines, they're going to intersect to form 4 right angles. So we can say in step 9 that, in step 9, we're going to say that angle QSP and angle QSR. Now let's take a look at those two angles. That's this angle QSP and QSR are right angles. So I'm going to mark that in the diagram, okay, my pair of right angles. I didn't finish. Here's our right angles, okay, and the reason that that is true is because we have a theorem that says anytime 2 lines intersect and they're perpendicular, that's going to give us a total of 4 right angles. Okay, so now if I have a couple of right angles, you might remember the very first theorem that we proved was the right angles congruence theorem. So since those 2 angles are right, we can say that angle QSP is congruent to angle QSR. That's because of the right angles congruence theorem. All right, so then I'm going to go ahead and put another A out here. So now you can see in our little tally here that we have 1, 2, 3 pairs of sides congruent, 1, 2, 3 pairs of angles congruent. So now we can say in step 11 that triangle PQS is is congruent to triangle RQS because we have satisfied the definition of congruent triangles. Okay, so we have shown that the two triangles are congruent by showing that we have 1, 2, 3 pairs of sides and 1, 2, 3 pairs of angles congruent. Okay, so that proof took quite a bit of time because we had to show 6 pairs of corresponding parts congruent. Well, I have good news. That's the last time that we're going to have to do that. From now on, we're going to be able to show triangles congruent using some shortcuts. So let's go ahead and start learning those shortcuts. So let's start learning those shortcuts for proving two triangles congruent. The first shortcut is a postulate called the side-side-side postulate. And it's called the side-side-side postulate because it says the following. If 3 sides of one triangle are congruent to 3 sides of another triangle, then that's enough to guarantee that the two triangles are congruent. All right? So let's mark that on this diagram over here. Let's mark one pair of sides congruent, a second pair of sides congruent, and then a third pair of sides congruent. So what the side-side-side postulate says is that if we have 3 sides of one triangle congruent to 3 sides of another triangle, that's enough to guarantee that the triangles are congruent. We don't have to prove or worry about any of the angles. All right? So you can see how now using that postulate, it's going to be a lot quicker to prove two triangles congruent. If we just know that the 3 sides of one triangle are congruent to the 3 sides of the other, that guarantees that the triangles are congruent. Okay, our second postulate, called the side-angle-side postulate, says if 2 sides and the included angle of one triangle are congruent to 2 sides and the included, should have made this blank a little bit bigger, sorry, included angle of another triangle are congruent, that is enough to guarantee that the two triangles are congruent. So now let's mark what we mean by 2 sides and an included angle. So on these two triangles, let's mark one pair of sides congruent and then a second pair of sides congruent. And then the included angle would be this angle, okay? It's the angle that is formed by our 2 sides. So let's mark those included angles congruent to each other. And so what the side-angle-side postulate says is if we have that information that we have 2 pairs of sides congruent and the included angle congruent, that's enough to guarantee that the two triangles are congruent. We don't need to worry about the other pair of sides or the other angles. Okay, and then we have a third shortcut for proving triangles congruent. It's called the angle-side-angle postulate. And it says if 2 angles and the included side of one triangle are congruent to 2 angles and the included side of another triangle, that's enough to guarantee that the two triangles are congruent. Okay, so let's mark that on the diagram. We need to mark 2 angles. So let's mark this angle congruent to this angle and this angle congruent to that angle. Okay, now, so what would be the included side? Well, the included side would be this side that the 2 angles have in common. All right, so mark that pair of sides congruent, and the angle-side-angle postulate guarantees that that's enough to prove that the two triangles are congruent. We don't have to worry about the other parts. Now, I forgot to mention that these postulates can be written in shorthand form. So draw a box around this statement, okay? This is the shorthand way that we will write the side-side-side postulate. It just says SSS, it will be our shorthand for 3 sides of one triangle congruent to 3 sides of another triangle, and that will imply that we have congruent triangles. For our side-angle-side postulate, just draw a box around this. That's how we'll write it in shorthand. And then the angle-side-angle postulate we'll write like that. Okay? So those 3 were postulates, and then this last one is a theorem, which means we can prove that, and we're going to do that in just a minute. The angle-angle-side theorem says if 2 angles and a non-included, I'm not going to be able to fit this in here, a non-included side of one triangle are congruent to 2 angles and a non-included side of another triangle are congruent, then that's enough to guarantee that the two triangles are congruent. So let's mark that in this diagram. So we need to mark two pairs of angles congruent. Let's mark this pair of angles congruent and then this pair of angles congruent. Okay, so those are two angles. So now, we've already talked about how this is the included side, so we can pick either of the other two sides and call them a non-included side. So let's pick this side and that side. Okay, so that's another shortcut for proving that two triangles are congruent. And how we'll write that in shorthand, we'll just say AAS implies congruent triangles. Okay, so we're going to prove this theorem, and when we go to prove it, let's remember that we have three postulates that are in our toolbox of reasons, of justifications, and we might want to pull from one of those to prove the angle-angle side theorem. Okay, so let's prove the angle-angle side theorem. So what we're going to prove is we're going to prove that triangle GHS is congruent to triangle KAL. Or KLM. So if you would, somehow I'm missing a letter over here. If you could go ahead and label vertex L, we're going to prove that the two triangles are congruent. So remember the hypothesis of the angle-angle side theorem says if we have two angles of one triangle congruent to two angles of another triangle and their non-included sides are congruent, that's enough to guarantee that the triangles are congruent. So let's go ahead and let's mark what we're assuming to be true. We're assuming that angle G is congruent to angle K and angle J is congruent to angle M. Okay, we're also assuming that HJ, which is a non-included side of one triangle, is congruent to LM. All right, so given that information, we're going to prove that the triangles are congruent. So let's go ahead and start with our given statement. Now, sometimes we write all the given. In this proof, I'm just going to put the first two pieces of given information. I'm going to say that angle G is congruent to angle K and that angle J is congruent to angle M. Okay, reason that was given. Okay, now if you remember from last time, we talked about a theorem called the third angles congruence theorem, which said if we have two angles of one triangle congruent to two angles of another triangle, what has to be true about those third angles? Well, those third angles have to be congruent as well, don't they? So let's go ahead and mark them congruent. 1, 2, 3. I'm going to put 3 arcs on each of them. And then in statement 2, I'm going to say that angle H is congruent to angle L, and the justification for that is the third angles congruence theorem. Okay, so now that I have those angles marked, take a look at what we have now. Now notice that I have two angles and an included side of one triangle congruent to two angles and an included side of another triangle. So that's enough. If you recall, that was one of our postulates. The angle side angle postulate says that if an angle, two angles, and an included side of one triangle are congruent to two angles and an included side of another triangle, that's enough to guarantee that the triangles are congruent. So let's go ahead and in step 3, let's list that third piece of given, that segment HJ was congruent to segment LM. That was given. And now since we have those two angles and an included side congruent, we can say that triangle GHJ is congruent to triangle KLM, and the reason is because of our postulate that says angle side implies congruent triangles. Okay, so now let's take a look at this next example, and what the directions say is it says, can you prove the triangles congruent? If so, provide a reason and write a congruent statement. Okay, so take a look at what we're given in this pair of triangles. We're trying to prove this triangle congruent to that triangle. Notice we have one pair of angles marked congruent and one pair of sides. So that's just two parts. That's not enough. but we can use some previous knowledge. Remember, if you look at these two angles are what we call vertical angles. And we proved a vertical angles congruence theorem that says if two angles are vertical, then they are congruent. So let's go ahead and mark those angles congruent. And so now look and see what we have. Now we have two angles of one triangle and one side congruent to two angles and one side of another triangle. So that's enough to say that the triangles are congruent, but what is the reason? Two angles and one side. We have to decide if this is an angle side example or an angle angle. And I hope you can see that the side that's marked is not an included angle, so we can say that the two triangles are congruent by angle side. So let's go ahead and write that reason down. We're going to say that angle side implies congruent triangles, okay? And now let's write in that first line, let's write our congruent statement. So what I'm going to do is I'm going to go ahead and name that first triangle. I'm going to name it triangle PQR. Now you can name the first triangle anything you want, but once you've named that first triangle, that dictates how you're going to name the second triangle because corresponding parts have to match up. So if you look at the picture, notice that angle P, whoops, I didn't mean to do that. Let me erase that. Okay, notice that angle P has one arc on it, so it would correspond to angle T. So the first angle we'll name is angle T. Then I have angle Q marked. Well, angle Q has no mark at all, so that means it would correspond to angle S. Okay, and then last but not least, we have angle R. And angle R in the first triangle obviously corresponds to angle R in the second triangle. Now that is just one correct way to write the congruent statements. There are other correct congruent statements. It's just once you have named that first triangle, you have to make sure that you name the second triangle so that corresponding parts match up. Okay, so let's look at our next example. I see two pairs of sides congruent. That's not enough to prove two triangles congruent, but what I want you to notice is that the two triangles share a side. And because congruence is reflexive, we know that that side is congruent to itself. So let's go ahead and mark that with 3 tick marks. Okay, so now you can see that we have 3 sides of one triangle congruent to 3 sides of another triangle. So we can say that these two triangles are congruent by side, side, side. We'll say side, side, side implies congruent triangles. And now let's write a congruent statement. So I'm going to name the triangle on the left, and I'm just going to call it, let's call it ADC. ADC, and you could name it anything. I'm going to call it ADC, but once I've chosen that name for the first triangle, that's going to mandate how I name my second triangle. So here's how we can figure this out. If I go ADC, if you kind of look at the sides, I have a side with 2 tick marks followed by a side with 1 tick mark. So I want to be consistent in my other triangle, so we would want to say triangle CBA. That's 2 tick marks followed by 1 tick mark. So that's going to be called triangle CBA. Okay, and then the next triangle, notice we have a pair of right angles. Those right angles will always be congruent. We have a pair of sides marked congruent, and then notice also that the two triangles share a side. So that side that they share, we can mark congruent to itself, and that's going to be enough to prove that the two triangles are congruent because we have 2 sides and an included angle, and we have a side angle side postulate. So that guarantees the triangles are congruent. So side angle side implies congruent triangles. And now let's write our congruent statement. I'm going to call the triangle on the left, I'm going to call it triangle LMK. And if I call it LMK, then I need to call the other one NMK so that corresponding parts match up. So let's say, we'll say it is congruent to triangle NMK. All right, so then let's finish our notes with a couple of quick proofs. We're going to prove two triangles congruent. Notice that there's not a whole lot of space here because we don't need a whole lot of steps. Unlike that first proof that took 11 steps because we had to use the definition of congruent triangles, this is going to be much easier because we have those shortcuts now. So let's start with what we're given. We're given that segment AD is congruent to segment BC. We're also given that side AB is congruent to side DC. Okay, so to get the triangle ABC, let's see, ABC, this triangle, congruent to triangle CDA, well, we only need one more pair of parts congruent, and since the two triangles share a side, that's going to be our third congruent part. So we're going to get these two triangles congruent by side, or two triangles congruent by side, side, side. So let's start with our given statement. We'll go ahead and list both pieces of given. We're going to say that side AD is congruent to side BC, and segment AB is congruent to side DC. The reason is it's given, all right? And then notice that the two triangles share a side, so we can mark that shared side congruent to itself. 1, 2, 3 tick marks. And so in step 2, I'm going to say that side AC is congruent to side AC. It's congruent to itself because of the reflexive property of congruence. And so that's enough to guarantee that the two triangles are congruent. So in our last step, we'll go ahead and say that triangle ABC is congruent to triangle CDA because of the reflexive property of congruence. Okay, so that wasn't too bad. Let's take a look at our last example. Okay, again, we're going to try and prove two triangles are congruent. Let's mark what we are given. We're given that an angle DAB, that's this angle, is congruent to CEB. Okay, we're also given that DB is congruent to segment CB. So that gives us two pairs of corresponding parts. To get a third pair, notice that we have, again, a pair of vertical angles. And vertical angles are always congruent to each other because of the vertical angles congruence theorem. So let's number those angles. Let's call one of them angle 1 and the other angle 2. Okay, and let's get these triangles proved congruent. So let's start with our given information. We're given that angle DAB is congruent to angle CEB. Okay, reason, given. We're also given that segment DB, let's go ahead and just include this in step 1. Segment DB is congruent to segment CB. Okay, so there's two pairs of parts. Step 2, we're going to say that angle 1 is congruent to angle 2, and the reason is because of the vertical angles congruence theorem. If two angles are vertical angles and they are congruent. And then last but not least, that gives us, let's mark those vertical angles congruent. So this angle congruent to that angle. So now notice that we have, 1, 2 angles congruent, and we have a non-included side. So by angle, side, that was the angle theorem, the angle, side theorem, we can say that these two triangles are congruent. So I'm going to say in step 3 that triangle ABD is congruent to triangle EBC. And the reason is because of our theorem that says angle, side implies congruent triangles. Okay, so now thank you for your attention in this video. Go ahead and get your worksheet and get going on it. And if you have any questions, be sure and ask me when I see you again in class.